afterwards. So who was the person that actually touched it, so on and so forth. All of that is very important because your data needs to be made available for search and discovery by other people, especially when you want to realize it, or when you realize that you need help when it comes to sharing and collaborating on these data. Because ultimately, at the end, when you get to your publication, and all scientists at some point must publish, and you have to get your data out there, is that your data will become just a small stepping stone in somebody else's much larger project. And you need to make sure that you've kept good care of your data all the way to the end so that the next person can easily pick it up and do much greater things than you ever imagined. And the 1KP project is an example of this. Not to say that they don't have great data, they have fantastic data. And they must get it out there for other people to use. 1,000 plant transcriptomes have been sequenced at once and then cycled. But we'll make those voices loud.
It'll be available even on their website.
Yeah.
It's not there yet.
And in essence, when we think about all of iPlant's technologies, and I'm only giving the 1KP project a hard time because Nicole is highly vested in it. It's great to see someone who's actually involved with the project. Is that iPlant's technologies, for all intents and purposes, are involved with dealing with the life cycle of data. If there were no data, iPlant wouldn't need to exist. But we're sort of running into this incredible revolution, all of you are leading the charge, of watching biology become a highly quantitative, data-driven science. And all of you are going to be, since you're here, interested in that revolution and leading that revolution and helping people in your lab become good members of that revolution. It's going to be a quiet revolution, I think. So when it comes to iPlant, you had a great overview of a lot of the tools and services. When it comes to how computational architecture is often represented in what we'll call the hardware folks or the software folks, is they like to draw what we call layer cakes. At the bottom, hardware. At the top, high-level tools and services. And so what iPlant gives you access to are cloud systems, high-performance computing systems, structured data storage systems, and of course, raw metal storage. A bunch of low-level services for giving you access to this stuff. Some higher-level ways that you can use it that allow you eventually to build tools that a variety of people that are not as computationally savvy can have access to. We usually refer to these as end users, and the folks that are accessing these lower layers, computational users. And iPlant does provide you access to get a hold of these depending on what it is that you need in terms of getting your work done. So often, this layer down here is a lot more flexible. This stuff out here, a lot easier to use. But it's limited in terms of what you can do. So what we're going to talk today is we're going to talk about the storage system and the DataStore. And I want to really emphasize that this is built on a software platform known as iRods. Dave, you mentioned iRods. What does iRods stand for?
Integrated rule-oriented.
D.
Huh?
No, I don't know. D. Data
Storage. Yeah.
Data system. Yeah. This is a phenomenal software project that's really that is designed to help with the big data challenges. And it lets people stand up a set of hardware that will easily grow, can be federated across multiple sites, have built-in replication, a lot of metadata management, and a huge amount of power underneath the scene. The reason I want to emphasize this is that this is how iPlant uses and adopts technology. It's leveraging things out there that are under active development by other groups that have been working on these problems for a long time, bringing them in, and then being able to make them come together with a bunch of other resources. iPlant is standing on the shoulders of many, many, many giants. And iRods is one of my favorite giants to stand on. And what I want to emphasize about the DataStore is that it is secure, scalable, reliable, redundant, and very, very important, high performance. It has the means to let you move a lot of data quickly, provided that you're on a network that you can take ruthless advantage of. So when it comes to moving data, if you use the right means for doing it, what the DataStore will do is sense how much bandwidth you have available, and then use 90 to 95% of it. So that lets you move lots of data quickly, or upset the people next to you. I prefer to do both. So, iPlant DataStore. many different ways to access it. What this is just a movie of me connecting to it through a protocol known as WebDAV that allows me to mount it as a folder on my Mac. And then I can just go ahead and browse, look at it, play, see what's inside of it all at the same time. Do not take notes on this. Unfortunately, WebDAV has been shut off because people have figured out unique ways to abuse it. But we will eventually get it opened back up again. But all I wanted to emphasize about this is that although this is convenient and it looks cool, it's only really good for browsing and it's not good for moving data. Incredibly, incredibly slow due to the protocols and the software stack required to make this work and look as smooth as it is. Another way to access it is through the discovery environment. As Nicole was referring to, this is one of iPlant's flagship software systems. It has a great view of your data, and we'll have a chance to go through some of this to play with some of your data. But what this is showing you is the exact same view of your data store as I see over here. So the data store exists as a separate entity, a cloud resource to which we can connect from many different means. Another one of those, and that is my personal favorite, is from the command line through a suite of tools called the I commands. iRods has that letter I in front of it. The commands, the power iRods, also have an I in front of it, so it's called the I commands. For those that are familiar with running around on the shell, the I commands will be very familiar. To change a directory in your data store, on the command line, Hagen, what do you type?
To change directories? CD.
Right. Now, as I told you about this whole I phenomena, how do you know these things?
We had to write a program for deleting iRods data.
Next time, I'll give you the answer, which is like, I just know stuff. Just like you, Cole.
Yeah, really cryptic. Yeah.
So I'll come over to this side here. Command line experience.
I didn't realize they had sequence created so bush.
That is my secret project.
Oh, cool. That's
Yes.
a great bush to sequence.
He stores it in the refrigerator upstairs.
It smells like all get out though.
Yeah.
Totally. If you're interested in helping with the Creosote Genome Project, come talk to me.
Done.
We've got lots of great work to do. And my current stumbling block is I have tissue in a friend's freezer, but I need to mail it to somebody.
I'm a man on the ground. Yeah, I can do that.
Trust me, you don't understand. Like going out to the field with like a container of liquid nitrogen,
Yeah.
I needed help. That kind of.
I'm experienced in the blue room.
Say no more. I've got some projects that I need some help on. Okay. So where was I? So changing directory with CD. How do you list the contents of a directory in Unix in the command line?
Man, it's been a while since I've been
You can ask the person
But
next to you for help.
Directory, you just put dir.
That's Microsoft. I should have been more specific. Unix.
LS.
LS.
Okay.
Okay, so if the command to list the contents of your directory is ls, can you guess what it is inside of your data store?
Not always.
If changing directory was cd and in the data store was icd and listing the contents of your directory locally is ls, what do you think it is in the data store?
We like eyes.
And we like the letter I
Yeah.
in front of the command.
I've seen it put in a few times.
Okay.
Yes, yeah.
We'll just assume that you said ILS, and I will give you a bunch of kudos on that front there.
Oh,
So
ILS.
these are how this is how the I commands work, and this is a phenomenal way to go ahead and move your data, especially from the command line. This here again giving you access to the same set of data that you see underlying over here. This is showing some fancy stuff with file viewing and the discovery environment and how I can do that over here. But these are all connected to the same resource. iDrop, which we'll get a chance to review. This is standalone software that, how many people here used computers back in the early 90s or before? Good. For those of you that weren't born yet, get ready for a history lesson of what life was like back in the early days. So back in the early days when you wanted to move data back and forth between two computers, what you would often do is you'd fire up some program that would give you two directory trees, and you would drag and drop between the two of them, and then you get a little progress meter. This was often, and this is what I'm going to do here, so I'm going to find a file and I'm going to drag it from my local files over into my iRods files. I'll go ahead and drag those back and forth. This is very reminiscent of a whole set of software for transferring data. Do you guys remember this? Remember all the way back to like the early like command line only, things like Midnight Commander and stuff like that, going way, way, way back.
DOS copy command or
DOS, Xcopy, all those kind of fun ways to like manage your files. Yeah. So this is a recollection of that. So the other thing I want to emphasize about this is not only are there different ways to access it, and that different people are going to be comfortable with different means, is that the different technologies that are being utilized underneath the hood allows you to have different amounts of transfer power. And what I mean by that is that when it comes to iRods and its ability to move a lot of data quickly, when it auto-senses your bandwidth and tries to use up to 90% of it, what it's doing is it's doing parallel file transfers. So it's opening up multiple threads, reading from your file in multiple places, and using as much as it possibly can to go ahead and move it. This does not do that. This does it in some situations. This does it awesomely. And this one does it pretty well. So different things will have high throughput transfer, and other ones won't. We also have an API if you want to program against it, the DataStore. This is going over RESTful-based mechanisms. Not good for moving data per se in and of itself, but it's a good way of managing stuff within your DataStore. And we'll have a workshop dedicated to the science APIs as well. So when it comes to the DataStore, a bunch of different ways to access it. A couple different ways to do high throughput, high performance transfers. The discovery environment will have an option that will launch a Java Start program. That Java Start program can use multiple threads and be high performance. So this can do high performance transfer as well. Getting Java Web Start to work through the web, easy or difficult process? I'll go all the way to the very end. Have you ever played with Java programs launched through web? No? How about you?
I would say a quirky process.
A quirky process. That's a very good description of it. Sometimes it works flawlessly. Sometimes your computer snaps on your fingers and you don't know why. So I like to basically say that it's available and it sometimes works. In terms of how fast the DataStore is, these are just some tests that I did last year. Basically moving 100 gigs of data from a server in Berkeley over to the iPlant DataStore here. And I was able to move about 100 gigs in a little under 30 minutes. To put that into perspective of how fast that is, that comes out to about 1 gig every 18 seconds. And then what I did is I did a bunch of benchmarking just using my standard desktop Mac in terms of how long it took to copy the same amount of data. So if you're copying from a CD, 320 seconds, using SCP, which is a way to copy between two servers, single-threaded, 150 seconds. An external hard drive, 36 seconds. Flash drive, 30 seconds. The DataStore, 18 seconds. And then the only thing that was really faster was copying between two internal hard drives. So under pretty real-world situations, you can move a lot of data.
This time in seconds for 1 gig or for the whole 100 gigs?
For 1 gig. Coming back, normalized down to 1 gig. But I would take a long snapshot and then try to normalize it off of that as best as I could. These are just rough benchmarks, but just to give you a feeling of what high performance means. Again, if you're moving a terabyte of data, no matter what you do, it's going to take a little while to move a terabyte of data. There's a lot of things that can come into play. So metadata. If you come in, we'll take a look at this. When you come into the discovery environment, there are great ways, very easy ways for you to see your files. If you click on that little double thought bubble or speech bubble, it'll open up a place for you to go ahead and edit metadata. And so this is metadata about a genome. What's nice is not only being able to add your own metadata, but as we link and build this platform with other computational resources, we can go ahead and add metadata for you automatically. So this is a platform that my group maintains that Nicole referred to earlier called Koji. And what this does is it manages a bunch of genomes. And if you're logged into the platform, you have the opportunity to have this platform automatically export data to your data store. So you're like, oh, I want this version of the MACE genome inside of Koji. I'm going to go ahead and send it to my account in the iPlant data store. And then Koji not only sends the data and drops it off in the data store that you then can use with all of other iPlant's tools and services, but also goes through the process of marking it up with metadata that it has about the genome. So it tells you the type of sequence, it's unmasked, where it came from. It came from Koji, and here's a link back to it. The original source of those data, this came from masequence.org, and so on and so forth. So I love metadata, but I also trust that almost nobody is going to do a good job of maintaining their own metadata, especially when it comes to these analyses. So we try as much as we possibly can. I mean, this audience excluded. I know that if I were to take a look at any one of your laptops, it would be an artwork of organization. You would have one folder on your desktop that just says, perfect. And underneath there is the most glorious way data's ever been organized. True or false?
Definitely false.
I was going to have Way validate whether or not you're lying. But having our computers, help with that process, automatically tag things as data passes through it is a really good thing. And one of the things that people often ask for, and it's sort of a hard thing to teach, is what are the best practices when it comes to data management? How do you organize your data so that it can live within this idea of a life cycle that can move on? And it's only built through experience. We can give you some hints along the way, but we want you to not look confused and to take great care of your data. Will you promise me that as you generate all these transcriptome data, you will take good care of them? You will hold them and you will cherish them, and you will treat them with the respect that they deserve?
Oh,
Don't
that's
let
a
him scare
lot.
you.
It's a lot to ask of your data. I know you'll come through. It'll take a little while, but you'll get there. So, metadata and best data practices. Start practicing, start doing it. It's really important. How many of you guys have ever generated a data set 10 years ago? You guys never did, how many of you did science 10 years ago? Did stuff 10 years ago? Had a computer 10 years ago? Really?
2004, for those of you who.
2004. You can't be that young.
No, I think I used a computer before.
Think so? Have you ever been able to find one of your data sets from 10 years ago?
Yeah, using the search thing for a top there, just type in what you're looking for, and then eventually you find stuff. Or
It's usually roasted.
it takes forever.
I find my really old data kind
The file beer.txt got a hold of it and completely corrupted it. I don't know what happened. Yeah, no, it's one of those things where we do see data living a lot longer. And a lot of the old ways that we do our archival methods, unless you actively try to do some to maintain it, it just falls away and disappears, never to be found again. I had, I kid you not, the most awesome MP3 collection circa 2001. And I am so glad I burned that into the long-term archival methods of writable CDs, and none of those things work anymore. So that none of you guys can go back and double check to see how awesome or lame that collection of music was. And I can tell you nothing. So the other thing I do want to emphasize is that iPlant does make it very easy to post quick share links. This here is I'm going to go ahead and show this, and this is a slightly outdated movie. But when it comes to sharing data and managing data, what iPlant is really striving to do is not only let you deal with more data, but to do so in a much smarter way than you were doing before. In terms of a little bit about the architecture of the iPlant DataStore, we do have a bunch of servers here at the University of Arizona's data center that are comprising the iPlant DataStore, and that these are getting replicated to iPlant's partner site at the Texas Advanced Computing Center, and that this replication is happening behind the scenes, so that your data not only has multiple copies here in Arizona, but it's also copied at multiple sites. What this means is that the underlying software system for this, iRods, is that if you decide to use your data and you're using iPlant's computing grids, that's located here at the University of Arizona. Your data located here is accessed. If you're hopping onto the supercomputers at the Texas Advanced Computing Center, you're smiling. Do you recognize this computer?
Yes.
Dave, you're the only one here that I hope can recognize a Commodore PET.
I do, I don't remember much about it.
The Commodore 64 didn't look too much different.
Well, this has the built-on monitor, keyboard, and built-in data transfer device.
The cassette tape.
A cassette tape.
Yeah.
These were the same things you would listen to audio on.
Right.
You could imagine how fast and how much data you could store on that. Have you ever heard of a cassette tape before? Oh, wow. Okay.
We all need to go home then.
No, just consider yourself lucky. You are truly the future. And all we do is like roll in the past nostalgia of our old computing devices. I love the Commodore PET. But if you hop on the supercomputers, these are massive machines over the Texas Advanced Computing Center. And when you send data over there, those are automatically coming from Texas. So the software that underlies this really does a good job of making sure that it's going to understands where your data are, especially if they exist in multiple copy, what local resources have access to those data, and then make sure that those data are controlled appropriately. Cut down the amount of bandwidth that goes back and forth. Both of these, of course, are connected to our cloud computing resource, Atmosphere, one of the coolest applications out there. And when it comes to accessing the data store, regardless of the method, you're coming into the University of Arizona. The reason for this is that Texas Advanced Computing Center is servicing a very large high-performance computing community, and they often have some pretty intensive data needs. So by staging here, this replicates when it can behind the scenes. We're able to give you access to a lot of stuff behind it. So hopefully by going through this, what you're able to sort of walk away with is that the iPlant data store is secure, scalable, reliable, redundant, high performance, and also connected. So, how many of you guys have ever moved? What's the most amount of data you have ever moved? Biggest set of data, biggest file. What's the most data you've ever seen?
Hundreds of gigabytes.
Hundreds of gigs. You?
Yeah, 500 gigabytes.
Getting close to half a terabyte. You've done the KP project. Have you posted into the terabytes?
Not terabytes.
Same range there. How about you guys? Terabytes?
Like a single file,
Just the collection.
like probably a terabyte.
Probably a terabyte, yeah. When you start moving big amounts of data, hundreds of gigs, terabytes, and you start to move beyond that, it will take a long time and it can be a little slow as you go through there. And you may run into some problems. And so with this class with so many computationally savvy people, you probably already actively think all the time about what happens when data leaves your computer and arrives on somebody else's computer. It goes from your hard drive to a network, to a building network, 505, to the campus network, off to the wild, wild, unknown west of the internet, back to another computer network, to a head node at the iPlant data store. This is actually a much more complicated process because there's many computers that make up the data store, to network card and then written out to a hard drive. Just realize that at any one of these points here, it can represent a point of failure and a point where some problems can occur. So when it comes to moving data, what do you think tends to be some of the big problems of moving data? If you all had, for example, 100 gigs, so we're going to do a live experiment. And I was going to say, let's all move 100 gigs of data simultaneously right now. All of you are on the Wi-Fi. What would happen? You're laughing, you're giggling.
Robert would be angry.
It'll go slow. Exactly. You are competing for a very limited resource that doesn't scale very well. So when it comes to moving data, just keep in mind where your bottlenecks are. If you're moving data on campus here, do you want to be on the newest building to do it or the oldest building?
Oldest.
Generally speaking.
Because there's less people using it.
This is
Right? Everyone there is not even thinking computers.
Good answer. Yeah, usually what it comes down to though is the newer buildings have the best network.
They don't go back and update the older buildings.
Sometimes they
They update into
update.
the ceilings, so they have to update something.
People are keeping jobs. What they're doing, nobody knows. But dust is created, wires are getting moved.
Buried treasure. Gotcha.
Exactly. So usually, if it's working, they don't go back and upgrade it, and the newer buildings usually have the best and fastest. So often you can, get 2 orders of magnitude improvement in moving your data just by walking to the newest building on campus. Just one of the things to keep in mind. Buildings built back in the 80s still have probably 80s networking hardware. And the limitations. They may upgrade it in terms of the pipe going into that building, but the internal networking hardware and the switches, wherever they may be, may not have been. And the improvements do improve pretty slowly. Number of people on your network. Are you going wireless? Are you connected? How many different internets do you have to hop across? And a big thing to keep in mind too is how fast your computer can stream data out. So I'm looking at most of you and you all look like you have pretty new computers. Anyone here have a computer with a spinning hard drive on it? A laptop with a spinning hard drive? Solid state? You don't know? Shocked.
I have a spinning hard drive on mine. So
Yeah.
You have a spinning hard drive on yours?
I can't keep up on that stuff. It's got sentimental reasons.
I'll ask you questions later.
Right.
So yeah, if you have a spinning drive in your laptop, chances are it's going to be one of the slow, low power ones. And that your network can stream data a lot faster than your hard drive can pull data off of it. Likewise, if you have a hard drive, you know, your colleague has sent you that 2-4 terabyte hard drive. That's an external drive, and plug it in. You're limited by your USB port. You know, are you on USB 2 or USB 3? How fast can you move data back and forth? And so there's a bunch of things you need to think about in terms of really how to maximize moving data around. So iPlant DataStore, free your data. A bunch of ways to connect to it because different people have different needs, but the good thing is that it's all in one place. So life cycle of data, and this is where iPlant fits into it. We are going to move on to some hands-on, start playing with this DataStore a little bit with the amount of time that we have left. I do want to say that if you are interested in sort of the state of the state when it comes to massive data analysis, I highly, highly, highly recommend Frontiers in Massive Data Analysis by the NRC. This came out last year. Very interesting read all the way through. And I'll leave a quote, but I'm not going to read it right now because I do want to get on and give us some time to play with the hands-on and have some fun with the DataStore. So, any questions? Are you all awake? Of course, all of you are still awake. Are you reasonably amused? Okay, good. So now we get to the really fun part, which is playing. So, pull up a web browser. If you have any problems, please raise your hand. One of us will have an opportunity to come over and help you. So, when you want to get to the DataStore, where we're going to start is through iPlant's discovery environment. If you want to get to the DataStore, or you want to remember where an iPlant resource is, you can always just use Google, or remember that data and that iPlant C is an alias to iPlant Collaborative. If you're like me and you have a hard time typing in C's, B's, B's, and L's, all in the same URL, you can just use iplantc.org. Data will hop you over to the iPlant discovery environment. Go ahead and log in, feed in your credentials, and jump on into the DataStore. What's nice about the DataStore and the iPlant discovery environment as a whole is it actually remembers your state from the last time you were logged in there. So any windows you had open, whatever directories you had browsed to will still be there. But everyone logged in?
Not yet.
If you're not, raise your hand. Data. Oh, do you still not have your iPlant account?
She may not have validated the link.
Oh, you might have to go to
Did
your
you
email
validate?
and validate.
All right.
You did validate it?
Yes.
Where are you going, Dave?
Check, I need to
After
write your
Ryan says
password
he's
down.
gonna tell me what to say.
I did.
I won't.
Let's go to the big group.
He's going
Here we
outside.
go. Here we go. 0.
Yeah, we're waiting for it.
But-
Be
You want to say water?
right?
Well,
And then click on the DE here.
okay, yeah, we only have like 20 minutes or so. I'm happy to hang out a little longer and help you guys too.
Not too much longer because there is something coming in after this.
Oh,
30.
let's book through this. I'm going to show
It's
you the
okay.
cool stuff and I'll leave
So
the cool
this,
stuff.
okay, did anybody else who's logging into the DE the first time get an error message? Yes. Perfect. Can you get a screenshot of that for me, please? Sure. Thank you.
Yeah, so we'll explain why that error message happens, but not right now. So once you're logged in, you have 3 icons on your left. One says data, one says apps, one says analyses. You'll get a much better overview of the discovery environment, but briefly, and then future one. Data brings up your data view. This is a link to the data store. Apps, these are which applications are available for you to run your data through. And then analyses, this is a list of previously run analytics that you've done on your data using apps, and of course your data. So click on the data icon. This will bring up your data window. As you take a look at your data window, on the left is sort of the major areas that you have access to, your username being one of them. And then you have community data. These are publicly available data sets. Shared with me, these are things that people have shared with you explicitly. Trash, I have no idea what goes in there. Then of course you can mark things, give them a star, and those are your favorites. So what we're going to do is I'm just going to go into my, my home directory, and I've got a lot of stuff in here. And so the first thing that I'm going to do is I'm going to see that I have a file directory called temp2. So if you don't have any, how many people here have nothing in their directory, and how many people have a couple of pre-built directories in their home directory?
Stuff, because I used it
Yeah.
before. but-
Okay, you got regular stuff in there. Anyways, don't worry about it. If you have some other questions about it, we can auto-populate some stuff that goes into it. But once you're in your data store, what I want you to do is let's go ahead and create a new directory. So you can click on File, and this should be hopefully pretty simple for people that have used a modern operating system in the last 15, 20 years. But click on File, you can say New Folder, and then you can go ahead and type in your folder name, and you'll go ahead and create a folder. And then what you can do is you can upload some data. So I'm going to go to my file called temp2. And this is what I created at the last workshop. And I'm going to go ahead, I hope you guys create a directory called temp. And then you can go ahead and upload some data. And so when you upload data, you've got three options. You can use the simple upload from desktop. This is using standard web technology for moving data. It often works, but it's not going to let you move a huge amount of data. The web was not designed with big data in mind, and this simple upload will definitely break for data sets above 2 gigs, and often start to break down for data sets at around half a gig to a gig, depending on a bunch of factors. Your network, your speed, how fast these things, how reliably these things can chat back and forth with each other. Bulk upload from desktop. This launches the Java Web Start program, which is basically a version of iDrop, that is called iDrop Lite, that allows you now to do parallel file transfers, as well as select multiple files. Use at your own risk. I don't want to have to go through the process of debugging it right now. But the other thing you can also do is if you do have a file that's on an FTP server or a web server, you could say import from URL. So you've got your link to some GenBank file at NCBI. Paste it in here. You can go ahead and slurp it down that way. But why don't you guys go ahead and upload a file. Just pick a small file if you have one. I'm going to upload this photo of my class
guessing.
eating donuts.
You might want to check and see though.
Why not?
Who's that? Oh, that's my old one.
Yeah, I'm just logging in as a guest. I'm sure there's nothing.
Yeah, there's probably.
So once you've uploaded it, you'll notice that I uploaded it to this directory and it didn't show up. And the reason being is this is a web-based technology. We don't necessarily have a trigger. It may refresh at some point to refresh the contents. But all you need to do is hit this little refresh button at the top, and it'll refresh the view of that directory, and my new file has appeared. So here's my photo. And if I click on it, I think we've got a JPEG viewer. So here I can show you my class from this morning. And what I have in my class is a punishment
I
that
believe
says,
you now.
if you show up late, yeah, so here's 4. There was one more person, 5 people showed up. Another person showed up with 2 more boxes of donuts. He showed up an hour late. But you can look at them, they're all, I can't believe this. Yes, we had 8 boxes of donuts for a class of 25 because of our punishment. I don't know how,
Can we get Nirav on that for
Nir-
real? Like when he shows up to meetings late?
he
has
needs
to
to bring
bring
donuts?
money.
Yeah.
Money.
Oh, trust me, I've tried to collect money out of this audience already, they won't give me any. But I think we might be successful.
You all know Nirav is like the
So-
15-minute rule, right?
Yeah, so when it comes to this file, Blake is like, oh my God, I have to have it. Can you share that with me? That's awesome data. I'm going to go image process